or kind of some applications in the real world. And at the end of this section, you see an actual real application people do in physics. It's actually a big physics question involved when it comes to this kind of stuff. But when it comes to applications of modeling, the biggest thing you want to do is always draw a picture. If you're a visual person like me, I always have to see what's actually going on. It makes it much easier to understand what to do when it comes to it. The answer for the test would be which one? Were you talking about like the simplification one, Jonathan? Like, is that what you're asking?
Yes, I was just curious. Did you want the simplified version all the way down, or are you okay with the answer?
They both would be fine. They're both would be fine. Yeah.
So you can, x equals 1 plus or minus 15 over 4 is okay.
X equals 1. Oh no. For like this one, you would have to actually simplify, giving it two answers.
Ah, okay.
Like if this is like radical 15, that's good like that because there's no full answer to give you a radical 15. Does that make sense?
Yes.
Yeah. So like for this one, you actually get a nice number. So you get two really nice numbers out when it comes to it. Yeah.
Okay.
Yeah. Once we get to the test and quiz, you'll see how that goes about. So don't stress too much when it comes to it. Yeah.
Right on. Thank you.
Okay. All right, so where was I? So the first thing you kind of want to do is always draw a picture, what's actually happening in the port, according to the problem. Next thing you want to do is label and identify any variables that are unknown to you, okay? And now when it comes to these variables, you have all the alphabet you want. You can put Greek letters, so it doesn't always have to be X and Y. It can be literally any numbers and letters you want when it comes to it. But we want to label what's missing and what's given to us in the question, okay? And the biggest one is what a lot of people have struggled with is number 3. We want to write an equation or equations that help us use to solve this problem when it comes to it. And that's sometimes, we just have to get it out random. Here I won't give it to you. I'll give you some major ones we're going to be dealing with itself. But in the real world, I have to pick up how in the world is going to help us out just from complete randomness itself. Okay. And the fourth one and the fifth one is pretty much just solve for the given variables and then just use the proper units. That's all when it comes to it, right? So the fifth one is pretty self-explanatory. If we're doing inches, feet, any type of unit, you just pop it at the very end and you're done from there. But the main focus is pretty much like 1 through 4 is the actual math behind this kind of stuff. Okay. Now, like I said earlier, I am going to give you some formulas for this section because you'll be using these ones here. And there's two here. It's the volume of a rectangle. So if you have a rectangle, let's see if I can actually draw it in 3D here. Let's see. Best I can do. So if you have a rectangle, so volume, so like a box, right? Literally like a box. The volume is the length times the width times the height. And you do length, here's the width, and the height. It goes up, right, when it comes to it. Area is much easier. Is just like a paper. It's just length times width. There's no height, right? It's just two-dimensional. Okay. So those are the two major ones we're dealing with in this section. The next one is called the Pythagoreans Theorem. So I don't know if you guys have heard of this. Maybe you've heard of it previously, but again, we're not going to go too much in detail of Pythagoreans Theorem. All we care about is the application of Pythagoreans Theorem. Okay. And what the Pythagoreans Theorem says, if I have a right triangle, so this emphasizes we have a right triangle, and we have sides A, B, and C, like that, where C is always the longest one, the one going down slanted. We know that A squared plus B squared equals C squared, meaning if you square the sides and add them up, it gives you the square of something called the hypotenuse of this triangle. But again, we're not going to go into great detail when it comes to it. Okay. So those are our 3 major equations we'll be using in this section here. Okay. Well, one extra one, which is a fun one here, if you guys are wondering. Okay. All right. So now that we have a little setup, let's actually try one itself. Okay. So the first example says find find two consecutive integers whose product is 110. Okay, interesting. 2 consecutive integers. So let's just start with this. What does the word consecutive mean? Anybody know? So consecutive means one after another, right? So that's what consecutive means. So can you guys give me like an example of two numbers that go one after another?
1, 2.
Yeah, 1, 2. Right? Those are consecutive. So 2 is right after 1. So essentially what this question is saying, I want to find two numbers that go one after another, like 3 and 4, 5 and 6, so forth, that when you multiply them, give you 110. Okay. But it's kind of hard, right? You know, where can I, well, 4 and 5 don't work. So how in the world we actually figure those numbers out, you know, without randomly guessing, right, when it comes to it. So that's why we go back over here. So we're going to label and define any unknown variables we have. So we know we're going to say x is, let's say, one of them, one integer. And let's say y is the other integer. Okay, so we labeled and defined some unknown variables. Now the question is, how in the world do we write some equations? Well, the question told us one equation, actually. Anybody remember what product means?
Multiplication.
Yeah, multiply. So we're timing. So we're saying we're having two consecutive, and when we multiply them, that equals 110. So therefore, we know that if I multiply these two numbers, that should give me 110. So we have an equation. X times y equals 110. Right, so we got that so far. Not too bad, right, when it comes to it. But that still doesn't get us anywhere, right? We still can't solve like for one of them, then find the other one because, you know, when it comes to it. However, they do give us something, a little hint when it came to this consecutive, right? So let's say 10. So 11 would be two consecutive, right? 10 and 11 are consecutive numbers. Here's a question. How do I go from 10 to 11? Anybody? So how to go from, like, you know, 10? What do I do to get to 10 to get to 11?
Add 1.
Yeah, add 1. Right? So that's all the case, right? If I add 1 to 4, that gives me 5. So that's consecutive. If I add 1 to 1, that gives me 2. So in general, if x is my first number, therefore my second number is x plus 1. Look at that. So I have an equation which I can't figure out x and y itself. However, I do now know the first number is x, and now I can rewrite the second number as x plus 1. And now I can now solve for one or the other. And now this just goes back to the last section, right? So distributing gives me x squared plus x equals 110. Focus. There you go. Now we solve. So that is right there, step 3 and 4. Or so actually step 3. So now what we're going to do is step 4. Solve for the given variables in the equations found. So we're going to solve for the variable. So bring this over. And now we just solve in general. So we can either, you know, factor if we can, different squares, not different, the quadratic formula, whichever you prefer. Hopefully this nicely just solves pretty nicely, but, you know, who knows? Hopefully we can or can't do it. So if we just factor in general, it's going to look like this, and this is 1. So two numbers when you multiply give you 110, and add up give you 1. I think 11 and negative 10 work. Yeah, I think those work. So therefore, it's going to be x plus 11 and x minus 10 equals 0. Setting each one to 0. And just solving in general, right? So subtracting here, x equals negative 11 and x equals 10. But which one is true? That's the question. All right, well, this is kind of weird, but we can always check, right? Our checking point is here. So let's suppose one of the integers is -11. So therefore, the next one is going to be, well, x plus 1, that's going to be -10. Does that work? So when you multiply -10 and -11, do you get 110? Yeah, you do. Cool. All right, let's do this one. 10 plus 1 is also going to be 11. And when you do multiply again, 10 times 11, you also get 110. Huh, so do we get two answers? Yes and no. Again, all goes back to what is an integer, way back in the day. So little pop quiz, integers are all the positive numbers, basically from 0 to infinity, the positive one is there, so no negatives. So automatically, you can just cross that out, and you know the numbers you're looking for were 10 and 11 to begin with. So we actually guessed that earlier. Pretty crazy. Okay. So before I go any further, any questions on this example we just did? You have a homework example very, very similar to that. I think the only difference is just changes this number here. All good? No questions? Okay. Let's try the next one. So a rectangular piece of metal has length twice the width. All right, so that's going to be probably important there. Twice the width. Squares with size of 4 inches long are cut from the 4 corners. And the flaps are folded upwards to form a open box. If the volume of the box is, all right, so they gave us the volume, so which means we're probably going to be using this volume equation right here, is cubic inches. What is the original dimensions of the piece of metal? All right, let's see. So it tells us we kind of have an open box. So let's just first make a rectangle here. Okay. Start there. And it says squares with sides of 4 inches long are cut from the 4 corners. All right, so we're cutting corners here like this. To do so. Now it tells me the squares, so these little squares are 4 inches long. So this is like 4 by 4 here, 4, 4, cutting them 4 here each side, like that. Okay, so we're literally cutting these out. And it says that once we cut this out, it resembles an open box. So it's kind of like that where this is open, right? Just like an open box. So you fold it up. Okay. All right. So again, before we go any further, any questions so far about our little drawing or how we did this? So all good? Okay. All right. So far, so good then. All right. So that's all step 1, right? Just figuring out what in the world they're asking us to do. Oh, and so for now, step 2, we know the volume is 1,536, right? And we also know, because we have an equation for volume, is length times width times height. Again, just going back to our equation up here. All right. So just like the last one, the question is how in the world do we associate these ones, right, when it comes to it? All right, so let's see. So if I cut these out, So right, 2, 2, 2, 2, 2, 2, 2, 2. In the question now, I have this open box. Well, we know this is going to be the length, right? This portion here, this is called length. We know this is going to be the width. But the question is, how high is this going to be? Or how tall is this box going to be? Anybody have an idea? So quiet. Well, let's just do an experiment. Let's suppose this is 4 inches and 4 inches, right? And I now cut it. And again, I do that all the way around, right? And now I fold it up. Like that. So the question now becomes, how high is it from here to there? Anybody have an idea?
4 inches.
Yep, 4 inches. It's exactly how much you cut to go up there. So from that concept, all right, we know how tall it is. Or in other words, we know the height of this box. So we know, so we just plug this in. So that's not too bad, right? We got one of the numbers we're looking for. Boom, we got 4. So now we just look for L and W and we're done. Okay. All right, so now we got to go back to our original paper and see what's the world happening here. Okay. So it says that the length is twice the width. So the length equals 2 times the width. Right, we know that for a fact, again, going from the scenario here. Okay. So therefore, instead of an L now, I'm going to plug this in. So again, just putting this in here. So that's what L means. This is a W, and now that's a 4. Okay. So far, so good. Again, you guys are more than happy to say if you guys are a little confused, right? So. Okay. Well, let's just clean this up a little bit, right? Let's just multiply, make this a little nicer to look at. So W times W is just W squared. And then 2 times 4 is 8. So we got that, right? So it's a little nicer to look at now, right? When it comes to it. Hey, we can now just solve for W. Look at that. So solving for W, we could just divide both sides by 8 and then take the square root. So let's just do that. So let's divide both sides by 8. So 1536 divided by 8 is 192. Right? And this is exactly what we did last time, right? The square root property. We're just take the square root of both sides, and we're going to plus or minus our answer. So about 13 point, let's see, what is it? 85. It's an 85, or negative 13.85. So pop quiz. So I know we have 2 answers, but which one can we cross out automatically? Because remember, we're looking at real world applications. So, you know, can we have a paper that's width of negative 13.85? Or, yeah, we can.
No.
No. Good. Good. Looks like you're the only one here today, I guess. All right. So that's we go. So our width is 13.85. Okay. Now we're actually almost done, believe it or not. So that's not our actual final answer because this goes back to just here, right? Remember, we cut out pieces here and here. So our actual width is an additional 4 and an additional 4 here. So we're just going to add 8 total to that to get our actual width when it comes to it. Okay, so our total width will be 13.85 plus 8. So roughly 21.85. Again, the reason why we add 8 is because we cut this 4 out and we cut this 4 out, so we have to add that back into the original paper. Remember, all we used was this format to go backwards now when it comes to it. Okay. And now that we have this portion, now we could find the length, but just timesing it by 2. So we just multiply this number by 2, and we get our final portion we want. And those are our original lengths and widths of our paper, or in this case, the metal sheet. And then we want inches, so we begin inches. There we go. Questions here? No?
So there's no general rule when you go back to add that 8. It's just real world is you understand that you already cut out 4 inches on each side, so you have to remember to just go back and add it.
Exactly. Yeah, because the whole point is you're taking this volume of this box you already have, and then you have to go backwards to the original piece of paper itself. The reason why is they want the dimensions of the actual piece of paper. So that's why you have to add in that individual portions there. And it doesn't matter, right? This could have been like, 5 by 5, and in this case, you would add 10 because you had 5 here and then 5 there, right? So the general format is always going to be kind of like this, if you guys want to think about it. So you always add in double whatever you took out when it comes to it. Does that make sense?
Yes.
Yeah. So again, you have a question very, very similar to this. I think the only difference is, well, this will change a little bit. And I think this is like a 2 by 2. So you would, at the end, you would add 2 here and 2 here. So you would add 4 this time once you got the W portion itself, or the L portion of the length, depending on what you're looking for. Yeah. Any other questions? Again, don't be shy, right? When it comes, if you have any questions. So that's what we're here for. I don't want you guys to be doing the quiz or the exam or even the homework and like you completely lost, right? So all good so far with these two?
For the test, you want steps 1 through 5 all written out, just how you did. You're gonna want something drawn and labels.
For the test, it'd be a little different. So you'll see an example how a test format's going to look like in a little bit. Yeah. It's not going to be like all of this. It's going to be mostly, it's either going to be, what's it called? Either fill in the blank or an essay question. So you just type in some stuff and you'll be done. You don't have to do all this. Yeah.
Got it.
Yeah. Any other questions? Okay. All right. So far, so good. So let's keep going then. This one's a little easier. If I overwhelmed you in the last one, trust me, this one's not so bad. So, okay. They're not all be like horrific like that one. Okay. So this one says a boat is being pulled into a dock with a rope attached to the boat at water level. When the boat is 12 feet from the dock, the length of the rope from the boat is 3 feet longer than twice the height of the dock above the water. It's a lot of stuff, right? Okay. Question is find the height of the dock. Okay, so again, let's draw a picture of what the heck's going on, right? So let's suppose this is you, right? And you're on a dock. So there's water, right? So here's our water. And let's suppose this is our little boat here. We're pulling in. Right. So you have a rope and you're pulling in this boat, right? You're just pulling it in like that. Okay? So that's kind of pretty much what the picture is going on here, right? You're just on a dock, you're pulling the rope back into the shore. Okay. All right. So when the boat is 12 feet from the dock, so from here to here, so this is 12 feet. length of the rope, so this is the rope, right? So the length of the rope from the boat is 3 feet longer. All right, so let's say rope is 3 feet longer than twice the height. Okay, that's a lot of stuff, right? But did you guys notice there's a hidden rectangle right here? Or not right here, hidden triangle right here. And this actually is a right angle here. Oh, it's very similar to something called Pythagoreans Theorem. So believe it or not, I can redraw this to make it kind of look like this now. Where this is our height, let's just say, and this is the length of our rope, you know, just for sake there. Okay. All right, so not too bad. Now we got it to from a picture. Now we got to an actual geometric. So we know, right, according to our equation here, it's if we square these two and add them, we get that portion there. So if we just do the same thing, we know we do 12 plus h squared is equal to r squared, right? So we kind of have an idea of what the equation we're going to be using, but we kind of have to figure out what in the world this is happening here, right? So once we get that, I think we can get to the rest of this problem. So let's just, you know, try to dissect what it means by this. Okay. So it says the rope, or we call it r, is 3 feet longer. Okay. So if I say I'm 2 feet taller than you, and let's suppose you're, you know, 5 feet. Just let me put this on the chat. So let's suppose you're 5 feet tall. Okay. And if I'm 3 feet taller than you, how tall am I? So how tall am I if you're just 5 feet tall and I'm just 3 feet taller than you? Yeah, 8 feet. So what'd you do? You added, right? So you added 3 to 5, that gives you 8. And so that's what the same thing process here means. So the rope is 3 feet longer, so we're going to be adding 3 to something. And just like last one means twice, so it means 2 times the height. And we called height to be h. So all of these words actually mean something in math. So we know r is equal to 3 plus 2 times h. Crazy, huh? Again, any questions so far at how we got that? Is everybody comfortable? Okay. I'm assuming your science is, you guys are good. All right. So now, just like last time, we're going to plug this whole thing right here. And again, just solve for h, just like we did for w here. We're just going to plug it in and see what we get. So it's going to be 12 plus h squared is equal to 3 plus 2h squared. Okay. All right, so we almost got there. So one thing we have to do now, we have to FOIL this out because we have 2 copies of this, right? So just a quick reminder, again, we'll get into a little bit more in detail of exponents later, but if I get squared, that means I have 2 copies of it. So we have to FOIL on one side.
Real quick, why is 3 plus 8 2h squared? Why is it squared?
Why is this squared?
Yes.
Oh, because originally we had r squared. That's why.
I see it. Thank you.
Yeah. So we're literally just insert it and keep everything else the same. Yeah. So we're just changing that R and substituting this instead. Yeah, but keeping everything else the same. Yeah. So on this side, we got the FOIL. So let's give a little quick note here. So it's going to be 9. And then, so let's just do 9 plus 3 times 2, 6h. Another 6h. And then finally, a 4h squared. So it's going to be 9 plus 12h plus 4h squared. Okay, and then the last thing I do is just bring everything to one side. So we're going to subtract 12. So subtract 12, and then subtract h squared. So subtract h squared. So on this side, we get a fat 0. And on this side, I'm just going to rearrange a couple things. So I have 3h squared plus 12h minus 3. So again, so far so good for this one. Assuming silence is not too bad, kind of comfortable. What we've done so far. Okay, and again, like this time, now we can just factor if we could, or we just use the quadratic formula, right? When it comes to it. So since I don't want to use, kind of want to use the quadratic, and hopefully this factors nicely. So we're going to check it out. So let's see if this factors hopefully nicely. So 3 times negative 3 is negative 9. 12 on the bottom. Let's see. I don't think anything factors nicely, right? No. 3 and 3. 12. So nope. Guess what? Quadratic formula it is, right? When it comes to it. All right. So we know A is 3, B is 12, and C is negative 3. And now we're just going to plug it in to our quadratic formula. All right. So it's going to be minus B plus or minus 12 squared minus 4 times 3 times negative 3, all divided by 2 times 3. Again, right, just using our quadratic formula to plug in what each one is respectively. All right, and now we just slowly simplify it as best we can. So this is 144. Minus makes positive. So what's that? I think that's 36. 4 times 3 times 3. Yep, 36. All over 6. So 36 plus 144 is 180. Now, unfortunately for these ones, we do have to go a little farther because they're real world applications, meaning we will actually simplify this out. So what I mean by that is we'll just take the square root of 180. And let's just say that's like 13, make it easier for ourselves, right? So we get x equals 12 plus or minus 13 all over 6, right? And let's suppose that we got our two answers. So x equals negative 12 plus 13 over 6, and x equals negative 12 minus 13 over 6. Okay. So now here, we're going to get 1 over 6. And over here, we're going to get negative 25 over 6. Now, does it make sense that our height, or in this case, our height of our dock is a negative number in this case? Because that's what we're looking for, right? The height of this dock here. What do you guys think?
No.
No, right? So again, We just cross this out, and so for a height of our dock is going to be about 1 inch above the water level, which is really, really small dock, right? But doable. So our height is, what is this in feet? Oh, in feet, yeah. 1/6 of a foot. So there you go. Small little dock we have. So again, any questions on this one at all? So again, notice the whole setup is setting it up, and then from there, we do exactly what we did last time, right? Just using the quadratic formula to slowly simplify it as best we can down. And again, since we're doing real world applications, I'll give you a hint. You just always knock off the negative value because, you know, we can't have negative length in real life scenarios when it comes to it. So any questions here? Are you guys sure? Silence is either good or very, very bad, right? When it comes to it.
Just curious if we want to factor using the X or snowflake method, whatever it is, could we just use the quadratic formula every single time and still get the same answer?
Yes. Yeah. So factoring only works when it does work, right? Like here it didn't work. So, but the quadratic formula will work all the time, no matter what the numbers are. That's a cool thing. So that's why, you know, it's a little bit more work than factoring, but if you can't factor, that's why this is always a go-to method when it comes to it. Yeah. I just was hoping that these would be a little nicer numbers, but you know, that's why I just picked 13. It was like 13.4-ish, but 13 is fine to go by when it comes to it. Yeah. But yeah, if here's a little tidbit, right? If you go into higher math, if you don't like factoring, the quadratic formula will always give you the same answers. It's just a little bit more work because, you know, you have to do the steps and to simplify that, but those will always give you the correct answers. So if you hate factoring with a passion, you know, just go through that, you get the answers. Yeah. So you'll be seeing a lot of this entire semester. So any other questions?